Hello, class. How y'all doing? Got 6 people here. How was y'all break? Hopefully y'all had a good break.
It was cold. It was cold.
Yeah, it was cold, man. I tell you. I went outside a couple of times just to take some pictures. It was cold.
It was pretty bad. I can't lie. I was like, this is unexpected.
Right.
We go from being hot and humid to all year, to all of a sudden we get ice on our roofs and trees and everything.
I'm telling you. And we back to 70
Yeah,
degrees.
I know we're back to
Yeah.
that's what I'm saying.
Yeah, but hopefully it kind of kills some of the mosquitoes, though, man. I tell you.
Yeah, that'll be I hope so too.
Yeah, because the mosquitoes been bad for a couple of years.
Always, especially
Yeah,
down here. Yeah.
I know. Yeah. So I looked at I didn't look at the last program. I looked at a couple of people the last program, but that second to last program, I'm gonna kind of go over because I think some people not quite getting it. The programming aspect of it. But I'll kind of go over the program to show you what's what. For the most part, some of you got it though. But what I'll do, I'll continue with the chapter 2, complete that, so we can have that assigned for the test and the quiz, and then I'll kind of go over the programs, those last 2 actual programs that you had to. Well, you did the string programs, which was somewhat whatever, but the calculations. I had some people to just do like C out and the value in a string, and so I want to try to get them to get up to par as to this stuff has to be calculated. Hold on, right quick. This is my boss. What's up, Miss Doré? Oh yeah. You asked me about the what? The furniture or something you asked me about? Yeah, but it's something else you asked. Yeah, I did look at it though. I said yes, and it was. Oh yeah, it was something about furniture though. Right. Well, remember I talked to that other school. Uh, uh, okay. All right, class. Yeah, my boss, he was going on, so I said, I got to get to class. Thought you were gonna tell me something and that'd be it, but all right. So let me share my screen. So where was I? Uh, okay. Oh, no, I don't want this screen. So what we're gonna do? We're gonna finish up on the chapter, and then we get started. Anybody have any questions? And like I said, I'll go over those programs after we complete this. If I can get this thing sized up like I want. Okay, that'll work. I think. I don't think so. Anybody with any questions? All right. Okay, so let's start off with variable assignments and initializations. So there is a difference between assigning a variable and initializing a variable. Okay, and so I'll take all this stuff out of here. Okay, so to assign a variable, I mean that's the initial. When to assign a variable, all you would do something is give it a data type. Like, we got char, and I'll say letter and semicolon. All right, that's declaring. I'm just saying, okay, here's a variable called letter. I want to be able to use it in my program. Allocate this memory location for letter. And it's to hold a what? A single character. Or I could do int value, right? Or I could do float, type float amount. All right. All these are just declarations. I'm just declaring that these are variables that I'm going to be using or should be using in the program, and allocate those memory locations for them. That's the. Oh, my battery low. My battery low. Hold up, real quick. All right. Now, okay. So that's declaring. To initialize a variable, when you introduce it to the program, you give it a value. All right. All right. So what I've just done here, I've introduced the variable letter. So told it if it was a char data type, and gave it a starting value of the letter A. All right. And the same thing here I could do with value. Okay, value is equal to 24. And I could do amount equals to whatever. So this is initializing. I introduce the variable and give it a starting point. Okay, that's initializing. Now, what happens is the students run into an issue understanding initializing and declaring, because what some students will do, they'll say, okay, Mrs. Sylvester, you said initialize value to equal to 24. So what I did was I did int value and then value equals 24. That's not the same thing, because what? Here I'm introducing it, but there's no value. Okay, there's no amount, there's no number assigned to the variable value. All right. So at that point, all you're doing is declaring it. And when you come here, this is assigning, because what? You don't have a data type. It's already been introduced as integer. So what? I'm saying set value to equal to 24. Assign value to equal to 24. All right. So that's an assignment statement. All right. So if I did it here, right, I'm assigning letter equal to A. And if I do, not float, my fault. Right. So what I've just done here is I've just assigned, I've declared my variables here, and I've assigned those values to each one of those variables. So if you see the difference between the question?
Yeah. So whenever you said whenever you initialize it, so you initialize it up there, that means you don't have to assign anything at the bottom because you already initialized it, right?
Right. But it can be changed though.
It can change
Right.
throughout like a program, like, let's say a number changed or a character letter changed. You could reinitialize it or just change it.
No, just like, okay, if I do this, if I do say like if I take value, I did value equal to 24, then I could say C out, and I don't even have to say C out. I could say C out value, right?
Yeah.
And then I could say value is equal to
36 something.
correct.
Yeah.
36. Then I do C out value. And
it'll
what?
come out 36.
Correct. Because I've overwritten that memory location.
Okay.
Right. That's right.
So, Professor, after you overwrite it right there for that value of 36, are all the continuous values after that set going to be 36?
Correct. Until you change it again.
Okay.
Right. So see, that's why it's called a variable. Because what? The value it kind of like variates from one to another. It can change. You understand?
Yes,
you
sir.
can you can use it for number 2. You can do it for negative, depending on negative, whatever, positive, whatever. It fluctuates as your program goes. And what you're going to understand over time is when you start writing programs, it's going to be very important to keep track of what a value is for a variable, because it makes a difference as to what your program is going to be doing. You understand? When you start putting if statements, like if we had something like if value is less than 45 or 25, you got me? And I start changing value to equal to some different numbers, depending on when they hit that if statement, it's going to do one thing or another. You got me? Right. So
Thank
that's
you, Professor.
All right. So that's why it becomes important to keep track of what they are. But like I say, this is assigning, and you could always assign a value of a variable of value, except, and I'm kind of going a little ahead, but when I do a constant variable, if I do const and I give up any data type, like say what I'll do, I'll take value out of here and I'll make it a constant variable. Okay. All right. I'm gonna value, take value out. All right. So I'm gonna take value out, and what happens? Const, and I'll do int value equals 24. What I've just done is said that throughout my program, whenever I'm referencing or using value, it will always equal what?
24.
24. If I even try to assign it the value 24, it's going to give me
syntax.
Correct, because I'm saying I'm trying to change it. So if I go in here and say value equals say 21, I'm going to get an error. See here, and I'm going to run it. I'm going to show you what the error message says. When I try to debug it, I didn't want to do. All right. It says what? Value cannot assign, value, that's the variable. You cannot assign you cannot assign to a variable that is constant. That constant means it stays the same. So you cannot change it in your program. I could use it in an expression. I could say something like amount is equal to that time value. You understand? Because what? It's going to take 24 and multiply times 1.28. Got me? So I could use it in an expression, but I can't have it to be overwritten. The value of value. I'm using value. The value of value. All right? Everybody got that? That's the only time where you cannot change a value of a variable, okay? If it's constant. Now, all right. So here, like this is unit sold equal 12. There's no data type. So this is a what? An assignment statement. Okay, so that's an assignment statement. So an assignment operator, which is the equal sign, assigns or copies a value into a variable. When the value is assigned to a variable as part of the variable definition, as we talked about, when you got a char, int, float, double, then it is called an initialization. So everybody understand the difference between initializing and declaring, all right, and assigning, because they're all different. Because sometimes in my program, I think if you saw the program I graded with the feet and inches, the program said to given the value 73 and 49. So they were given. So you could have initialized or you could have assigned, but not say CN the values and then calculate, because that's allowing the user to put in a different value other than the two values I gave you. All right. But like I say, you got to just understand the lingo so that you know how to write your code. All right. So here they're showing the program right here. This is being initialized. Months is being initialized to 2. Days is being initialized to 28. All right. Because I have the data type, variable, the value. Variable, because the data type and the value. So those two are being initialized. All right. So here we got initialized, here we got initialized, here we got initialized. So they're all being initialized to a certain value because we introducing them with a data type and giving the value. All right. So, but look at this statement here. Flight number, we got int flight number equal 89, travel time equal travel time, departure equal 10, and distance. In this statement, we have 2 variables that are initialized and 2 that are not. 2 are initialized and 2 are declared. The 2 that are initialized is flight number and departure. Travel time and distance are just what? Declared. All right. So you see how they have multiple variables in that statement, but 2 of them are declared and 2 of them are initialized. All right. The keyword auto. What auto does is it's kind of like it relieves you as the programmer from deciding on what a data type should be for a variable. Okay, like say 100. 100 we know is an integer value, right? It's a whole number. So if we do auto amount, the computer will automatically take it and assign it to be of integer, because it's a whole number. But then we do auto interest rate, we see that it's a what? A decimal. If we do auto stock code and we put the value in one value, one byte, which is one letter, and we put it in single quotes, it'll take it and say, oh, that's a char. But then look here, we got auto customer num. It's of a whole number, and we put an L at the end. So it say, oh, let's make that automatic a long int. Okay, so that's how you use auto. Auto just go in and set the data type for you, where you don't have to determine what the data type is. All right. The scope. Now this becomes important when you start sometimes trying to use the same variable in 2 different scopes. All right, because it can make a difference. A variable scope is the part of the program that has access to the variable. Let's look at a program. Let's look at this program here. What I'm gonna do, I'll take this out, and like I said, we'd have a program in here. But if I did something like this, I'll take this up. If I did something like this, and I'll say int cost equals 24. So if you look at this program, this main is a function. Outside of this function, I've created a variable called cost. and initialized it to 24. But what I've also done is made this variable cost global, which means no matter how many other functions I create in my program, cost will be known everywhere in the program. Somebody got me? Cost is a global variable. It will be seen and recognized everywhere in the program. Now, if I just simply take this, so the scope of cost here would be global, would be throughout the entire program. No matter where I write code, it'll be valid. But if I take cost and that initialization statement, and I put it inside the main, I've just changed the scope of cost to be only in the main function. Cost is only recognized in my main function. If I create another function and I try to use cost in it, it'll give me an error. I'll give you an example. Okay, I'll create a function, all right? And you created the function in the header file, but I'm gonna create a function in the main function. So I'll do the prototype. I'll say void, and I'll say sample. And I could call it anything I want, all right, as long as it's a valid name. All right, valid, okay, sample, all right? So now, it's green because it's not necessarily an error in the syntax, but there's no reference to sample, all right? So now I can do void sample, SMPLE, all right? And then here. Now, here is where I specify what I want to do in sample. Now, watch this. In sample, I'll try to say cost. See out cost. I'll just do it just simple see out. See out cost. So now, notice what happens here. It gave me an error on what? The variable what? Cost. Now, cost is declared, is initialized in the program. But remember what I said. Cost is only recognized inside the what? The main function, because that's the scope of cost. It's not a global variable anymore. It's a local variable, local to the main function. Now, remember I said before it was global? So how do we make it global? If we take it out of here and we put it here, all of a sudden now, look what happened. Now the computer recognized what cost is, because cost is global. It's known what? Throughout the entire program. So you see the difference between a global variable and a local variable? Now, when I run the program now, I can, it's gonna give me the output, upon include here. Oh, that's right. It's gonna give me the output if I click here. Did it give me the output? I might need to run it again. Debug. Oh no, it did it right. But before I can see the output, I need to tell the computer to execute that function. So to execute that function, just like y'all execute the function in the header file, what's the function name? Called sample, right? Remember in our header file was normally, some people change the name, but we had an example called head. So here, if I wanted to execute this function, the statements in that function, I'll just say sample, semicolon. Now what? It's gonna declare my function called sample. It's gonna initialize a global variable called cost. Then I'll go into the main, and it's gonna say, oh, execute sample. Go to sample. Okay, output the word cost, colon, space, and then output whatever the cost is, and 2 new lines. Can then return back here, and then return 0, we exit. All right. So if I run it, all right, now you'll see, look, cost and 24. All right. But like I say, just by simply taking this out and moving it here, I'll put it before, okay, right before that. Put it here. All I've done, I've just made it local to Maine, and it can't be done. Everybody see that? Everybody understand that? Got it? Hopefully you got it. Now, but there is a way that I can take this value of cost and pass it to this function and use the value of cost. All right. They call that passing variables. You can passing a variable by value or passing a value. All right. What I can do is all of a sudden now I could create an argument. When I call sample, I want to pass cost. Okay. Now, but then here, then in here, there's some things I got to do. But if you notice, before I do that, when you're dealing with a function, you have the prototype, which tells you what the function is, what it looks like, and what's being called, the name, and then what's being returned. All right, that's the prototype. You have the function call, and then you got the function definition. If you remember those 3 things, you're pretty much on your way. But then there's some things you got to do. If I want to call cost, if I want to use cost when I call a sample, I'm gonna have to do some things. I'm gonna have to go here and say what's the data type of cost? Cost is of integer. So this saying I want a prototype called sample, and when I call sample, I want to pass an int value. In my call, I just call sample and I tell it what integer value from that function that sample is in, that being called from, I want to pass. And then here I have to tell it I want to define sample, but then I want to what? Declare a variable of int. What's the variable name? It could be the same name, cost, but you got to remember the cost in this function and the cost in this function is 2 different variables because they got 2 different scopes. The cost in this in this function has the scope of the main. I'm passing the value to a variable called cost in this scope. Now you say, well, I don't really agree with that or understand that, Mrs. Sylvester. I'll show you. I could change this to amount. Okay. So now in this function, I have an int variable. I'm declaring called amount. So I can only use amount here. So what's happening is it's taking the cost, which is equal to 24, and taking the value of 24 and passing it to amount, and now I couldn't print out the amount or the value of cost, which is 24. So watch when I run the program. See? But now it's doing the same thing. Let me change something in here. So, okay. All right. So you'll really see that it is working. All right. So when I do that, so see what happens? Cost of past value is 24. So what? It took the 24, what cost was equal to, and it passed it into amount, and now we can use it in amount in that function any way we want to. We could put it in an expression. We could multiply it times something, do whatever we need to do with it, because we done passed that value and stored it into amount. All right. So you see how the scope of the variable is important, and you can run into errors if you're trying to deal with a variable and it's not in its proper scope, all right? And you'll be starting to change things in your program, trying to fix it, and you're really messing a whole lot of things up, all right? But now, the thing is, I want to show you, I think I showed you, because if I wanted to use cost, I could make it global. I don't have to pass a variable, take that int off, take this out of here, make this cost, and I could print the actual cost, and it'll work that way. But in working with global variables, many times it's hard to keep track of when that value change of that variable change, because you can have 10 or 20 different functions, and you have code throughout throughout those functions. And if you have a global variable, it can be changed at any time, and that can cause issues where it makes it harder to track, what's going on in your program. But if you have it as a local variable, you pass that variable, and then you're passing it from this function. It was what value when it was passed and whatever. It makes it a little better to debug your program. All right. So, any questions? All right. So the scope of a variable is important. All right. So if we look at this, what's the scope of value? The scope of value is what? The main function. All right. But what they're showing you here is that you tried to print out a variable before it was what? Declared and initialized, before it was actually initialized. So how will I print something if I don't know what it is, that it can be used, number one, and that the value was assigned after I tried to output it. So that's why you got an error here. You're trying to do something before a variable was introduced to the program. All right. Just like in many other things, you got arithmetic operators. All right. And it says generally there are three types of operators: unary, binary, and trinary. All right. And if you look here, you got the addition, you got subtraction, and addition is the plus, subtraction is the minus, multiplication is the asterisk. If you use Excel a lot, you know that the asterisk is the multiplication, not the little x. You're going to get an error. It's the asterisk. The division symbol is the slash, not the backslash, but the slash. And then we have that modulus. Many of you didn't use that modulus or didn't know, understand to use that modulus in that program that was given with the feet and inches. All right. But that modulus would have helped you to get the remaining inches after you got the feet. All right. But the modulus returns the remainder. You got to remember that, the remainder. Just like 17 modulus 3 is what? 2. Because what? 3 going to 17 5 times with a remainder of 2. So that's what you got to remember. The modulus returns the remainder. And it's, like I say, a whole number. All right. So, like I say, addition, we should understand addition, subtraction, multiplication, division, and then the modulus. Now, one important thing, and I always tell my students, even in 192, even in 194, you always solve an expression on the right and then store the value on the left. Okay, he said, what you mean, Mr. Sylvester? What I mean by this is, look at this statement. Amount equals 4 plus 8. This could have been x plus y, x times y divided by 3, whatever. You always solve for the expression, and that expression should always be written on the right-hand side of the equal. Then whatever the results are will be stored to the left side of the equal sign. Now we know in math, you can say what? 4 plus 8 equal amount. That's understood in math, but not in computer science. In computer science, you always have the value that you find, or the expression on the right, and you store the results on the left. Okay, always. I don't care what programming language you use. That's the policy. That's the procedure you have to follow. Otherwise, you run into all type of errors. All right. So this program, what it's doing is calculating uh, a person's hourly wage. Okay, and so also it even trying to find out overtime. So the overtime may take it a little bit, a couple of steps further, because what you may have to find out what the overtime hours are before you actually add the overtime rate, overtime salary plus the regular salary, all right, or regular wages, all right. So that might be an extra step, all right. But this is just a small one. This one didn't, because normally what happens with overtime, you have to find out if the value is greater than, and we never gotten to if statements yet. But they gave you the base rate, they gave you the regular hours, and they gave you the overtime hours, which made it much easier, all right. But most times you would get one value, like you would get like what's the hours worked, and you might get 50, and you'd have to write an expression to say, okay, regular hours is equal to 50, not 50. Well, if regular hours is greater than 40, then regular hours minus 40. I mean regular hours. Yeah, no. Then regular hours equal 40 automatically because they work more than 40 hours. Otherwise, you're going to give them the regular, whatever those regular hours were. All right. So that's some stuff you'd have to calculate. And then for overtime, if regular hours is greater than 40, then you would do the regular hours minus 40, which would give you the remainder of the 10 would be the overtime hours. And I say regular hours. Overtime hours would be regular hours minus 40. All right, so that's some things that would have to be done, but this is just a simple program where they gave you all the values, and then they calculated what those two was. All right. Now, and if you notice, they calculate the regular pay by using the base pay time regular hours. The rate regular rate time the regular hours. Then for the overtime, they did the overtime rate time the overtime hours. Then they added the regular wages time plus the overtime wages to get the total, and then they output it. So simple as that. Dividing. Now with division, there's some tricky things that can happen with division, and I'll show you. And it depends on your data type. So what I'll do, I'll take this. I'll take this out. All right. So what I'll do, I could do something like int x equals 3, y equals 2. All right. And I'll say, all right, float them out. Why is this? All right. So now, if I have this, I can say amount is equal to x divided by y, right? Now I can do cout now. So who could tell me what would the output be? I'm dividing 3 by 2 and storing it into amount. So who could tell me what the output would be or should be? Or what should the answer be? 3 divided by 2 is what?
Brady and Min said 1, if that's correct.
Okay, right.
Yeah, Brady and Min said it, in the chat. And then,
so the answer that would output would be 1. Now, why would it be 1? The reason why it would be 1 is because if you look at the left side or the right side of the equation, you have what? An int and an int, correct? An integer divided by an integer. 3 is an integer divided by 2. And they both of what? Integer data types, correct? So if I divide an integer by an integer, the results will be in integer. So no matter if this is float, it's going to store an integer value here. So if I run this, I should get what? 1. All right? See? I got 1. But we know what? The actual answer is what? 1.5. Now, the thing is with that is I would have to do something to where one of these values is of float data type, okay? So what I can do here, I could do something like this and float on y equals 2.0. Now, what happens is when I debug it, all of a sudden, now I get the what? 1.5. Okay? So what happens is the computer says, okay, well, the first time, I have 2 integers that being that's in this expression. So I can only return an integer. But then when it says I have a float and an integer, it promotes to a float, right? It takes integer has a lower precedence than a float, so it'll take the expression and promote it to float. All right, that's just like me doing this. I could do this: 3 divided by 2, 3 divided by 2, integer divided by integer. Okay, debug that. I'm gonna get 1. All right, it's gonna give me 1, an integer divided by an integer. But then if I say 3 divided by 2.0, which is the same values, because 2.0, you're not really adding anything to the 2, but it promotes the 2 to be of what? Float data type or double. And now when I run it, I will get the what? 1.5. So that's something you need to pay close attention to, because when you start writing expressions and you're trying to mix integer and float in an expression, or you got all integers and you're doing some type of calculation where you divide or whatever, you got to pay close attention that you don't lose some of the value of your of what your results should be. All right. So just be mindful of that. All right. Be mindful. All right. So, and that's what this part is telling us. This is an int divided by int. That's going to give us 2.5, but really it's going to output just 2. All right. But when I do this, 5.0 divided by 2, that's a float, that's an int. It's going to promote it. And now when I store the value here, it's going to output 2.5. All right. So that's basically what we did in the example we had. All right. All right. Let's see. This is the end of the chapter. I thought it was going into it went back up. Okay. Yeah, I think, okay. Comments. Well, class, there's 2 types of comments. There's single line comments, and then there's multiple line, which is a block. And simply put, if I put a // on a line, from the point of that // to the right of it is the comment. Notice I could comment an entire line by starting off the line with a // all right? Not backslash, but //. And so everything from that point on is a comment, no matter if it's valid C++ statement. Look here, I have a valid C++ statement here, and then after that I got // and then holds the hourly pay rate, a comment. So the comments start from this point on, and anything after that would be commented. This is valid. Now, This is also called documenting your program. All right. There's two ways you can document a program, or you can actually do it internally, which is the comment statements, or you can do it externally by doing paper, documenting it on paper. All right, where you're documenting maybe your variable names, how the variables being used, flow charts, things of that nature. All those things are program documentation. Now, multiple comment lines. What happens is, if you remember here, we did what? Slash, 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 slash. Nothing wrong with that. But if you want to comment a body of lines, you could start at the beginning with slash asterisk. So starting at the beginning of here, all the way down to here is commented, meaning that those lines are not executed. Okay, so that you commented from that beginning to that end. So that means you didn't have to go and put a slash slash on each individual line. A starting point, ending point. Everything from that to start to finish is commented. Now, sometimes programmers use that to work with their program so that they can say, well, I'm having issues with this particular section of code, so I'm gonna comment that block out and let it execute all the other code. All right. So, and it gives them like a little bit of flexibility rather than saying, I got to delete this out and then execute it. No, I'm going to keep it in, block it out, work with what I'm working with. And now little by little, I'll add my statements back in. All right. So it kind of assists you in debugging. All right. All right. But it tell you not to reverse the symbols or backslash. So you got to watch that. Remember, constant, name constant. We talked about that. A name constant cannot be changed. All right. If I do amount equals balance times 0.069, looking at this, 0.069 might be some kind of interest rate. All right. So what I can do, if I had to multiply something time this interest rate, say maybe 100 times in my program, rather than having to type 0.069 100 different times, I could assign 0.069 to a variable and just use that variable name. Because what? I could make a mistake and type 0.068, 0.05 something or whatever, and then my program is off. Or you write the program and put 0.069 100 different times in your program. And then something happened with the economy, and then the interest rate changed to 0.059. So what you have to do, being that you put 0.068 100 different times in your program, you're going to have to go and search and find and replace every place you had 0.068 to 0.065, well, 0.059 from 0.069. Or if you had put a statement, a constant statement saying const int or int con, not int, float const interest rate equals 0.069, and then use interest rate 100 different times in the program, and the interest rate did change, all you had to do was change it at that one statement, and it would be changed throughout the program. So those are some of the things you could do to try to keep the modification of your program down, to a minimum, and also keep you from making a lot of errors throughout the program. All right. So look what happens. They said this is an interest rate. So const double interest rate equals 0.069. So what? I can use in my 100 different expressions, I could use interest rate in all of those statements. And if I had to change this interest rate, all I had to do was come back here and change it here, and it's changed throughout my program. Done just that fast. All right. So that's all that they're talking about. All right. And look, it changes. So you change it, and they just change throughout the program. Another instance you might want to use a constant In math, certain things have constant values, like pi. When dealing with the circumference of a circle, all right, dealing with the diameter, trying to find the area, all this stuff. Pi is what? 3.14159. So what you can do, you could create a constant for pi and then use it in your program as pi. So look what they did. They created a constant. Let me do this real quick. All right. They created a constant called pi. And then what happened? They did circumference equal pi times diameter. They could have used 3.14159, but what? Depending on how many times you may use it in your program, 3.14159, and to change that or make an error typing it in, it would cause issues. So just using pi, reduce the amount of errors that you make of trying to retype the value over and over and over and over again. All right? Okay. Programmer style. Class, you all going to come up, hopefully, with your own programming style, whether it's the naming of your variables, whether it's how you tab your program, how you space your program, how you space your statements, all this. You're going to come up with a style because you're going to want that style to fit you. And so where you can, recognize, hey, that's my program. Oh, hey, I do this, that, whatever. All right. But look at this. This program will run. But what did they do? They put everything here on one line where you got using namespace, semicolon, int main, open close parentheses, the begin open curly braces, the declaration of this variable, all right? Then they went to a new line. This program will work, class. It will run. But what? It's somewhat confusing. Also, if you get an error on something on line 3, now you have to look through line 3 and try to find where the error is. But look at this program. This program have each statement individualized. So I got a declaration here. I got a declaration here. I have a cout statement here. I have a cout statement here. All right. Int main, curly brace here, curly brace here. So if I get an error on one particular line, undoubtedly that is on that particular line. It's like I'm not looking at 3 or 4 different lines at one time and trying to figure out which one it's on. All right. So, like I say, you want your program to be readable to where it's comfortable for somebody to go back and look through and try to debug it. And even with comments, they have some people who comment their program so heavily that the actual code is hidden because they got comments all around everything. And you got to pretty much really look through it to find where the actual statements are. Is it right or wrong? No. It's just that's the way they decide to do it. All right. But like I say, you're going to come up with your own programming style. All right. Okay. Anybody have any questions? Any questions? All right. So the test is open or going to be open so that you can take. You have until Monday in the quiz and the read chapter quiz. You have until Monday of next week to complete the test. All right. And so let's look at the program that was given. All right. Hopefully we have people on that want to help. So the first program that I'm talking about was the one where we had to take 2 numbers, all right, 2 in inches, add them together, and then find the feet and find the inches of the total. So I'll do something like int x is equal to 73 because I gave you 73. Y is equal to 49, right? So I gave you 2 measurements. Then we can have what I want to say. I'll say int ft and in. All right. So this is where we're gonna store the feet and the inches. So now, and then I need a total. All right. Total. So the program was to take the 73 and the 49, add them together, get a total. So what? Total is equal to, not 73, x plus y. All right? Now, because those two values was given. So now I have a total. Now I need to take this total and find out how many feet this total is. So what I can do is I could say FT, okay, the number of feet is equal to total, but then I'll do what? In order to find the number of feet in so many inches, I would what? Divide 12 into those inches. Because if 73, well, say now, let's take a number. If I had 36, so if 36 was the total, to find out how many feet 36 inches was, I would just take 36 and divide it by 12, and it would give me 3, right? So, being that I want to find the feet, I cannot try to get a decimal value. So no matter what the inches are, I want to get a whole number, right? Because the inches will be used to, I will use another function to find the inches, which would have been the point whatever part of if I did a decimal of the feet. So to get the feet, I'll just take the total and divide it by 12. And that's going to give me the number of feet that total number was. Now, in order to find out the inches, what do I need to do? Remember that funny math symbol, the modulus. The modulus returns the what? The remainder. So if I say IN, which is inches, is equal to total, and I do modulus 12, all of a sudden I'm dividing the total by 12, and whatever the remainder is my inches. So example, if I had 36 was the total inches. Total 36 modulus 12, what's the remainder? 0. Because 12 going to 36 3 times with a remainder of 0. So you understand what's happening? Because even if my total inches was 37, it would be what? 3 feet 1 inch. Because what? 12 modulus 37 is what? It goes in 3 times with a remainder of 1. So I'd have my 1 stored in the inch. So now I did it based on 73 and 49. So now all I need to do is output my data. So I told you though, I gave you a format. I told you to see out, and I'll just do the /t to move it over. And then and this would be X, all right? And then see out, and I'll just try to do the same format. Output Y. All right. So see, I'm trying to format the output to look like what the example I gave you. And then see out /t, and then I'll output and so many underlines. All right. Then I'll do the see out, and then what? /t, and then this would be I may move it. All right. This would be what? The FT. No, not FT. This would be total. All right. This would be total, right? And I ain't never did no new lines. My fault. But that takes it to a new line. So now, so I printed out the total. So now I'll just do a double inline here just to separate it. So now I need to print out my feet and inches. So I can do C out /T and then do FT. But then what? I got to print out feet. All right. And okay, I'll put a space here. And then IN inches. All right. What did I do here wrong? Oh, my string. All right. So this is what you had to do. You had to write the program, like I say, so because some people just wrote out in here like whatever the answer was in the string. No, you got to calculate it and print out. Because what? I could tell you to change that and use another value. You don't change this. The formula should, or the expressions in the program should actually calculate it. So when we debug it and we run it, see here, 7349, you get 112. I mean, 112, 1222. And then you got 10 FT, right? And 2 IN, all right? So everybody saw what I did here to manipulate my output to get that, all right? Because some people didn't have a space, they didn't write it where they had the spaces and it was all jumbled up, But that's what I wanted in the program. I wanted you to write the code. All right, you writing code. Now you say, well, Mr. Vessel, why? I could have just wrote out, like I say, some people just wrote out 10 FT period, 2 inches period. They just wrote that as a string. Can't do that because what if I told you go back and make this 72, all right? When I run this program, all of a sudden, now it should be what? It should automatically calculate 10 feet, 1 inch, not me go back and type it. You understand? The program did it. And no matter what I do, I could do 2 and 24. So that's 2. Let's see. I'll do 27. All right. So I'll do 27. So that's what? That'll be 2 feet, almost 24. 2 feet 5 or 7 inches, something like that. So if I debug it, the program should calculate for me. See, 2 feet 5 inches. So you understand what's happening. You write in a program where the program calculates it. You don't just say, okay, this is what he give me as an assignment. I'm gonna just take this and produce that output to just display on the screen. We did that with our escape sequences. Now the code here, you writing code to generate that output. All right. Now, some people, what they did, it was this. All right. I think I took a couple of points off, but what they did was this. They had X and Y. All right. Then what they did here, they said, see how, and I'm gonna just put anything /T. And I'm just saying enter first value and then CN X. All right, see out. Second value, my bar. And then CN Y. All right, so now With this program, what happens is every time I run the program, I can receive different values. But as I said, you got to know what, like I say, how the program is supposed to be, the information is supposed to be inputted. Is it already given? Am I supposed to input it from the keyboard? Am I supposed to read it from a data file or whatever? All right. But I gave you the two values, but some people did it this way. Like I said, I just took a couple of points off. All right, so watch. Look what it says, enter first value. So all of a sudden now I'm inputting something. So now I can put in a value. I'll say 15. Oh, what didn't happen? What didn't happen? It didn't happen. Can everybody still see me? Let me see something.
It looks like no, I can't, Professor.
Then my power went. Look like my power.
And then you just cut off.
Oh, let me. Oh, then let me see something. Went out again. What happened? What's going on? Change to internal. Why? I think my power going up. Let's see something. All right, so let me see. All right, everybody see me now? I need to share my screen. Do I need to share my screen again? Everybody see my screen?
Yes, sir. We can see it. We can see it.
All right. So what happened here is, if you notice, enter a value, enter another value. So now every time I run it, I can put in new values. So that's the beauty of what? Inputting data. Whether you're getting from a file or whether user input. But if I give you the values, then what? Every time you run it, you get the exact same value. But in learning, we show you how to do it that way when you first start learning how to code, to kind of get you adjusted to knowing what data is and stuff. All right. All right. So anybody with any questions? Any questions? The other assignment, let me go to here right quick. All right. But the other assignment, you had an expression, and the expression could have been anything. All right. So I started to do that. Yeah, what I'll do, I'm gonna take this program and put it in the module. So I can't do it. Yes, I can. No, I can't. Yes, I can. Yes, I can. Yes, I can. But I ain't gonna do it. It'll be too much time. I can do it. I'll make all this global. So I'm gonna make this global where I won't have to pass any values. Okay, paste that. Take this out. Take that out. Take this out. All right. And then I'll take this. Okay, I'm gonna cut this. I'm gonna put this in here. All right. So now, then I'm gonna write the other one. All right. So the other one, like you had an expression. I'm gonna do a comment. You had something like 4a plus 2ab minus something minus 4c, something like that. All right, you had an expression, something like that. So what it is, you were to like int a equals, a value. You could have have it read in. A could have been equal to, B is equal to 3. I don't think we had a C. A is equal to B is equal to 1. I don't think we had a C. All right, but I'll do a C. because it could have been any C equals 2. All right. So now, then in total, all right, or result, I'll say result, make it. Now, all you had to do was take that expression and write it out. So result is equal to 4, what? You could use parentheses if you wanted. 4 times A, right? Plus 2 times B, no, 2 times A times B, plus, I'm going to tell you, 4, well, minus 4 times A times C, all right? But now what you could have done, you said, well, wait a minute. What I'm going to do, I'm going to just group it to make sure, my expression works properly. But what? You got addition and subtraction always come after multiplication and division because the precedence is lower. So I don't think you have to worry about it, but you could have grouped it. It wouldn't have hurt. All right. So it would do this, then do this, and then add this, do this, then subtract that. All right. I need to put my semicolon. That's what I wanted. And then all you had to do was do something like C out. All right, and all right. So now, not a P. All right. So if I run this, it should give me. It should run out here. All right. See, look, result equal what? -4. So what? 2 times 4 is what? 8. All right. So then we got 2 times. Well, no, yeah. 4 times 2 is 8. All right. Then we got 2 times 4, which is not 2 times 4. 2 times 2, which is 4 times 1, which is 4. All right. So this is 4. So 8 and 4 is 12, right? But then we got 4 times 2, which is 8, times 2, which is 16. So 16 minus 16, was this 16? No, this was what? This was 8. Well, it was 8. Was this 8? This was 8. 4 times 2 is 8, plus 2 times 2 is 4 times 1.
It was 12 minus 16.
All right. Well, yeah, right. So this ended up 8 plus 4, correct. 8 plus 4 minus 16. So that negative 16 was greater than that side. So it was. So you do the subtraction and the sign go with the number. So it was a -4. So that's how we got that answer. And with your problem, it was basically the same, but you'll just initialize your values, and then all you could assign them. I didn't tell you. I don't think I told you to initialize them. I don't know. But then do your result, do your expression, this time this plus this time this, and then you would get your answer. And that's how you get. Because if I went and said, well, change A to 3, and then when you run the program, it should give you a different result. Because what? You're actually dependent on the program. See, -6. All right. So your program should execute to give you the results. All right. Now, anybody have any questions about the assignments? Because with the assignments now, like I say, you're not just writing it to just see out. You're writing it to create the code that will give you the results. Okay? Everybody understand? All right? So, any questions? Any questions? And then on the next class period, we're going to start with the next chapter, and you can read up on it. And let's see what the next chapter is. I think it's with like modules or something. No, expressions. So now we're going to be dealing with expressions a little bit heavily. All right. So they talking about the CSCI. We dealt with it, but we're going to show you some more about that. All right. So we'll get into that on next class period. All right. Any questions? Questions?
No, sir.
All right. All right. So to make sure you take your test, make sure you do your quizzes. You got till Monday. And like I say, read up on the chapter so that you'll be abreast of what we're gonna go over. Because next class period, we're gonna go over this chapter. We're gonna start the chapter. We not probably won't finish, but I'm gonna assign those assignments. All right. And you probably have 3 or 4 assignments again that you're gonna have to write the code. Again, you have to write code. Okay. And make sure you do use my header file. Some people didn't use the header file. So yeah, take points off if you don't include that header file. All right. Remember, header.h, have your header, and in that header, you're gonna have whatever, your name, the course name, due date, your name, all that stuff. All right, my name and whatnot. All right. Okay. So if nothing else, have a good one and
Yes,
do my
sir.
work and stay safe.
Always. Thank you, Professor.
All right, have a good one.
You too.
All right.